In mainstream physics, there are three major theories regarding the end of the universe. 1. Heat death. The universe will continue to expand and cool indefinitely until it reaches a state of complete uniformity, where nothing happens. 2. The Big Rip. Dark energy will gradually accelerate to the point where it tears apart galaxies, stars, and even atoms, disintegrating everything in its path. 3. The Big Crunch. The universe will eventually stop expanding and start contracting, collapsing back into a singularity, a massive superblack hole that consumes everything in its grasp. All three of these theories share a fundamental assumption. They treat the universe as either a mathematical infinite backdrop or space that can infinitely bend. However, energy filament theory doesn't subscribe to these abstract mathematical notions. Instead, it focuses on a logical framework and poses a crucial question that mainstream physics often overlooks. What if we don't actually understand the boundaries of the universe? If the universe is truly infinite, discussing its end would be meaningless. Energy filament theory makes it clear with three important points. 1. We reject the concept of mathematical infinities, along with the use of higher dimensional spaces to avoid tackling the core issues. 2. In our view, the universe must be a finite energy sea with specific boundary conditions. 3. The key insight is that these boundary conditions are not fixed, they can change. This now brings us to a more specific and practical question. What happens if the boundaries of the universe were to change during an extreme period of time? If such a shift were to occur, the energy sea of the entire universe could be simultaneously tightened, stretched, and driven into an extreme state. What would happen next? The universe might instantly revert to its early state, a soup core of energy filaments, just like the very early universe's boiling sea of filaments. This leads to a striking and unusual conclusion. Instead of everything collapsing into a single, all-consuming black holes, the entire universe might deconstruct, with galaxies disassembling, particles disintegrating, and the very fabric of the cosmos being broken down into energy filaments. The universe would, in essence, return to a primordial state of boiling energy filaments. So, the universe's endpoint could potentially mirror its origin in terms of material states. It's like a cosmic cycle, but one that's both fascinating and deeply troubling, because the boundaries of the universe and its structure would undergo a fundamental change, almost returning to the exact state of its birth. This leads to the larger question: if the universe's boundaries could change in such a way, then how do we truly understand the origin of the universe and the role black holes play in shaping it? This is a concept we will explore further in our upcoming Origins of the Universe series. Next, we will continue to break down the origin of the universe, starting with how particles and light first came into being within the framework of this theory. Tap follow, share it on New Physics, Clear Universe.